Welcome to Is the Earth Round or Flat? Episode 3, The Face of the Moon. In our first episode, we saw how physical distances between locations and their corresponding flight times refutes the flat Earth model by creating an impossible triangle, where the greatest length isn't represented by the greatest line. Then, in episode 2, we saw how star visibility, as divided by the northern and southern hemisphere, debunks the flat Earth model by the simple fact that constellations in the northern hemisphere cannot be viewed in the southern hemisphere and vice versa, indicating significant curvature. In today's episode, we'll be looking at the face of the moon and how direct visual observation of the moon can be enough to demand a globe Earth. This is true whether you're in the northern, eastern, southern, or western hemisphere. But first, let's look at two key lunar concepts: rotation and orbit. Rotation is when the moon, on its own axis, completes a full spin from start point to start point. When Earth does this, it takes 24 hours. Orbit is when the moon completes a full spin around the Earth, from start point to start point. When the Earth does this around the Sun, it typically takes 365 days. Once combined, you'll notice a very special relationship between the moon and the Earth, something called synchronous rotation. Essentially, the moon rotates on its axis only once each orbit around the Earth. One rotation, one orbit. The consequence for this for us Earthlings is that regardless of where you are on the Earth, you'll only see one side of the moon always. That's whether you're in India, South Africa, Brazil, Canada, the United Kingdom, or Australia. Regardless of where you are, the same features of the moon will be visible in your night sky. There is, of course, one major variation. The northern hemisphere sees the opposite view of the moon to the southern hemisphere and vice versa. For example, if you're located in the northern hemisphere in the United Kingdom, then you'll see the moon in this orientation with the Tycho crater near the bottom. On the flip side, in the southern hemisphere in Australia, you'll see the moon in this orientation with the Tycho crater near the top. This can be illustrated quite cleverly with this diagram. However, since I have Nando, allow me to use his soft white underbelly to demonstrate this phenomenon practically. Assuming this line is the equator, separating the northern and southern hemispheres, from the southern hemisphere you would describe Nando's cute squishy face as being nearest to the equator and his tail being furthest away. But as he moves to the northern hemisphere, you would then describe Nando's soft, sleep-interrupting tail as being nearest to the equator and his handsome cuddly face as being furthest away, the exact opposite of one another. Thus, the takeaway is that no matter where you are, you will see the same tidal lock side of the moon and all of its wondrous features, without exceptions. No ifs, ands, or buts. Now, before we go into any debunking, it's important to understand the argument we are trying to refute. According to virtually all the flat Earth models I've encountered, the moon, as well as the sun, are much smaller and in constant clockwise spin over the Earth. This means that the Earth is substantially larger than the sun and, as seen in this very cool GIF, responsible for the sunrise, sunset, day, night, and much more. There are a few flaws in this sun-moon dance relationship that we will cover in later flat Earth debunk videos. But for the meantime, let's focus on the faces of the moon and how gazing at the moon in different countries is enough to prove the Earth cannot be flat. To examine this, we'll be focusing on the perspective of the moon from New Zealand, Australia, India, Ghana, Brazil, Mexico, Canada, and Russia. And we'll be freezing the moon in this position. All perspectives of the moon will henceforth be in relation to this specific position. So when we want to see what a location should see of the moon, it's from this location relative to the moon's frozen position shown here. Now we will use our big brains and powers of spatial awareness to see what each of these 7 places should see if the Earth was indeed flat. Starting with New Zealand. In the real world, New Zealand sees the standard face of the moon and all of its features, as shown in this magnifying glass. But when placed into the flat Earth model, the face shown is vastly different to what we see in reality. Moving to Australia, despite the Australian moon showing the standard face in the real world, placed on a flat Earth, the Australian moon reveals an unfamiliar side that doesn't match observation. Onto India, despite the standard moon features on display in the real world, a flat Earth should reveal this side of the moon during an Indian night sky, something we don't observe. With Ghana, in this specific frozen position, is showing the same standard face of the moon we would expect in the real world. But that changes when the moon moves a quarter along its course. Here, the side is greatly different. Looking at Brazil, in this specific alignment, it looks close to what we would expect from the real world, but, similar to Ghana, as soon as the moon moves, the face shown will change into an unseen side in the Brazilian night sky. Going to Mexico, the standard real-world face shown in the sky is replaced with this unique and unseen view once placed in the flat Earth model, something inconsistent with what we can observe in the natural world. Moving to Canada, ignoring the real-world standard face of the moon on display during the night, a flat Earth model shows a truly rare side, the underside of the moon. Finally, ending in Russia, the common features seen all around the world are virtually absent and replaced with an entirely underbelly view of the moon, something expected on a flat Earth, but inconsistent with the real Earth. The question we have now is, if the Earth is flat, why do we only see one side of the moon? How is this possible on a flat Earth? You could say that the moon is symmetrical, with the same face on both sides. Well, we know from the 1959 Russian Luna 3 mission that retrieved a photo of the dark side of the moon that the back side of the moon is not symmetrical, so that can't be. But that's besides the point. Even if it was symmetrical, that would only solve a two-dimensional equation, since a symmetrical moon would account for the moon's appearance in these positions, but not in these positions, who would still see a different face of the moon. You could also claim that the moon, rather than being a sphere, is actually a disk that faces downwards. This would mean that everyone would see the same face of the moon as it spins above the Earth, but this creates a whole new problem. The moon would only appear circular when it's directly above the viewer, but the moment it moves along its course, it would lose its spherical appearance and the disk would be visually apparent at some point on the Earth at all times. But this isn't what can be observed on the Earth. The moon never looks like a disk in the sky. So, in essence, this flat Earth dilemma with the moon can only be explained by a globe Earth in tidal lock with the moon, thanks to the phenomenon of synchronous rotation. No matter how you angle it or argue for it, a flat Earth with a moon that shows a single face, as far as I can see it, is an impossible task. Thus, with the moon and its single face ubiquitous to the Earth, we can tally today's scores. Global Earth 3, Flat Earth 0. Thank you for watching. Please continue to support the channel by clicking subscribe, leaving a like if you enjoyed it, and if you agree or disagree, drop a comment.